Welcome back to another episode of Chadrick's Tech. Today I want to go back and look at the SSD data that I just recently presented. I looked at the Gen 4 versus Gen 5 performance, and I want to jump back in and do another quick comparison. I did re-render a lot of these same tests again, but I did it for a reason. I think I had a 5070 Ti, and that's what I was using for my main rig. But as you all know by now, because you're following along, is that I have a 5090. And I made a comment that I'm wondering, did I not see the Gen 5 performance because the GPU might have been a bottleneck? It's crazy to think that the 5070 Ti would have been a bottleneck, but you don't know until you test it. And so I had shocking results the first time I went through this. Like, I was really expecting more out of the Gen 5 NVMe drive, and I didn't see the read-the-write performance that is touted on the front of the box, right? And there's reasons for that, but at the same time, I need a little better explanation. Let's see if we can't come up with something else here today. And let's not use the 5070 Ti. Use the same setup and just limit. I'm going to even further limit the SSDs that I tested with, but now I want to compare the 5090 data to what I collected with the 5070 Ti. So these will be the same two systems that we use in the testing. Actually, I left the AMD test bench up there in case you wanted to see that setup. I've talked about it extensively elsewhere, and you will see the AMD test bench data listed with the 5070 Ti. I did not put the 5090 in it. Quite frankly, it's so far behind, I'm really unimpressed with it. But again, I'm not done playing with that. Maybe there's ways that I can make that better. Nonetheless, that's not the focus here today. Focus here today is the main office rig using a Gen 4, a Gen 5 SSD, and looking at 5090 data as it compares to the 5070 Ti data already collected. So this is your GPU comparison. There's your 5090 data, the stats versus your 5070 Ti stats. You can see that it truly is a step up. And if you've been looking at my previous MSI Gaming Trio 5090 comparison data with how it really compares with rendering and the general performance, there's a huge chasm of difference between the 5080 and the 5090. And it's much tighter between the 5070 Ti and the 5080. And quite frankly, it's not worth buying the 5080. In my opinion, the 5070 Ti checks all the boxes that you would want for productivity, for gameplay, for across the board, just having a GPU. If you're not going to swing for the fences and get the 5090. If you can swing for this guy and get a 5090, and you're obviously going to be happy with it if you can spend this kind of money. Now, prices are starting to come down. That's in our favor. We need a little bit more competition from AMD. Things are coming about. That's not what this is about today. Let's jump right into this information. So I streamlined the Samsung SSDs even more and just looked at the 9100 Pro, which is the Gen 5 drive, and the 990 Pro, which is the Gen 4 drive. Both have onboard cache, but you can see the advertised read and write speeds. It's not even close, right? Gen 5 should just run away with these types of tests. But as you know, in the last test that I did, I didn't get those results. But I did have drives that performed like this. And we know that because of the crystal disk mark data. And okay, so maybe some of this will look familiar to you. If you've not seen the last video, please go back and check out that SSD video so that you can see how this was set up. And I'm trying not to repeat myself and make these videos very long, but we need to get on the same page here. Okay, so what's in orange is the 5090 data that I added to the existing data that was already presented, okay? And I added another column of the GPU. Before, it was all the same GPU. I didn't need to differentiate, but now what's in orange is 5090 data. Okay, so the crystal disk mark, and again, I didn't organize it as you would expect from the sequential reads and writes. Those are those large numbers that are tattooed on the front of your box to get you to spend the money to buy the drive, right? I looked at it from the write, the random write data. I mean, because we're going to be creating content, video editing, writing larger files to the disk. So that to me, I think, is the more relevant benchmark, is to sort it by the random write speed. Okay. And you can see that there's not a huge difference here, but interestingly, the 9100 Pros were all at the top of the list, but it was a trade-off between the 5070 Ti and the 5090. Well, that's really not that big a deal because the GPU is not coming into play here, right? It's, does the drive have the level of performance that you need? Interestingly, though, the 9100 Pro is all the same stick. I only own one. That's it. So any variance you see here, and I wasn't changing around the location of the drive. If it said it was in a Gen 5 slot, there's only one slot it could be in this Master X motherboard. And there's only one drive that was used, only one system it was used in for this testing. And whether it was primary means you booted from the drive. Secondary means a different drive booted the device and it was in a Gen 5 slot, or it was in a Gen 4 slot. I actually tried to test whether or not you could just maximize the benefits by putting a Gen 5 in a Gen 4 slot. Obviously, you're not going to get Gen 5 speeds, but can you maximize Gen 4 performance with a Gen 5 SSD? And it's really a waste of money, as you would imagine. But anyway, it was tested, right? All right, so you've got reasonable performance down the list. So we're getting the benefits, right? There's what's on the front of the box. Your sequential read rates, 14,000. The 9100 Pro, I'm like, what happened here? Oh, yeah, duh. It's in a Gen 4 slot. So it's 7,000 read rate. Well, you put it back in a Gen 5 slot and you get 14,000. You put it back in a Gen, and this is inconsequential to whether or not you split the PCIe lanes, because if you're putting the drive into a Gen 5 slot, it ends up getting dedicated Gen 5 X4 lanes, and you rob from the PCI Express for your GPU bus. So you should see all of the performance out of your SSD because you now have dedicated lanes you've robbed from your GPU lanes. Okay, that's basically how all this is set up. And you're getting the touted benchmarks out of these drives. But can you put this speed to use when you're actually trying to be productive? So let's jump right to 3D Mark, the storage benchmark, and PCI Express test. All right, I organized it by the storage benchmark score. So the GPU, 9100 Pro, the 5070 Ti, the Gen 5 slot, and it was booted with the Gen 5 card. That was the top performance for the benchmark. Then the 5090 data in the primary spot got the second spot, only 2% back. All right, and you can see the PCI Express lanes, they're cut down. The BIOS took it to X8 and it's cut in half from what you would get if it was left in an X16 mode with the drive plugged into Gen 4, so the Gen 5 slot is not used, and so you're not cutting those lanes in half, and you get 43. And again, if it's an X16, if it's a 990 Pro in a Gen 4 spot, here's your scores, right? And so the PCI lanes are cut down. You're not getting stellar scores in a Gen 5 location, even though they are faster. They are at the top of the slot, but they're not twice the speed of when they're in a Gen 4 slot, which is unfortunate, right? So I'm not seeing blazing speeds while we're sacrificing the PCI lanes. So we've cut back the PCI lanes. What does that mean in terms of the GPU performance? Well, before we get there, let me just take a step back and look at Puget Bench. So Puget Benchmark 1.2.0 and DaVinci Resolve Studio 20. This is where I'm using the DaVinci Resolve Studio, using these two with the Puget Benchmark to see what kind of scores that we're going to get. What was our best score? Our best score was obviously the 5090s at the top of the list. They can process through the data much faster than a 5070 Ti. There's no shocker there, okay? So obviously, we're best to keep a 5090 in the machine. Now, what about the Gen 5 versus Gen 4 drive? And the top spot was the Gen 5 drive with the lanes cut in half with a 5090 booting the system, giving us a standard score of 15,790. If we use the 990 Pro and did not have the Gen 5 drive in the system and did not split our lanes, that was at X16, and it didn't, lose by much, by 0.3%. Then if we put the 9100 Pro in the device and split the lanes, but booted from a 990 Pro in the Gen 4 lane, so the Gen 5 card was secondary, but you're running on your primary card, again, you didn't see much of a difference. It's kind of a wash. But really, if you're being academic about it, splitting your lanes and using the Gen 5 drive is the fastest way to go when you're going to use Puget Bench and DaVinci Resolve, looking at all the different scenarios that Puget Bench can put DaVinci Resolve under, okay? Running a full gambit of tests. And the standard score is your studio if you're a paid user. Basic is if you're running the free version. You're more optimized to get the studio version, right? All right, so why don't we just leave it in the system with the lanes cut down? Well, do we lose our GPU speeds? Okay, let's look at that. Fastest scores, and we're doing average. This is Speedway, Port Royal, Time Spy, Steel Nomad. And then the average score, sorted by the average score. Look at the huge difference in scores. And again, that's 5090 for you. So the fastest average 5090 score was using the Gen 5 drive with lanes cut in half. And you got the top scores. If you had the Gen 5 drive in place and then booted from the Gen 4 drive and then ran the tests with the Gen 4 drive in place, but the Gen 5 drive was there splitting our lanes in half, it only was down by less than 0.5%. Not what I thought would happen, right? And then in third place was the Gen 5 drive is not in the system. This is like the baseline run. No Gen 5 in the system. The 990 Pro Gen 4 drive as the primary boot drive, running the tests on the Gen 4 drive, and not splitting your lanes from X16 to X8. And that was in third place by almost down 1%, 0.7%, right? They are so close. 25,700 to 25,900. And you got the best scores with the Gen 5 drive as the boot drive and splitting your GPU lanes in half. I don't understand why that is. Like, it's not supposed to be that close, right? Otherwise, are we not utilizing our PCI lane sufficiently? Or this Master X motherboard and this Gigabyte stuff, when you're splitting lanes, really is not splitting lanes, you're doing better? Like, how is this possible? Well, maybe there's a difference when you render. So let's look at the 4 different situations when you render in DaVinci Resolve And we're doing DaVinci Resolve Studio, and it's the same two 4K files. There's a small 4K file that's 21 minutes and change, and a large 4K file that's over 90 minutes long. And these are two videos that are on my channel right now. And all I did was put them in the system and render them. Render to whatever the configuration is here on the screen, right? For example, the fastest render time, and that's what I sorted by, was render time. And when you look at the chart, it's no surprise that the 5090 is the top of the list, right? It's going to render the files faster than a 5070 Ti. More grunt there, right? But what shocks me is the 5090 is at the top of the list. The 9100 Pro is also at the top of the list, even though we're splitting our lanes in half, but from X16 to X8. And whether you've booted from the drive in the primary or you've booted from a Gen 4 and then render to the secondary drive, which is the Gen 5 drive. The Gen 5 drive was in the Gen 5 slot. Render times are the same. Max read rate is only 120 meg per second. Averaged only 33. Max write was 113 megabytes per second. The average was 48. Temps, cool. No problem. But if you look at utilization, I didn't put this information there. I collected a lot more. I mean, you didn't have a total of 100% activity going on. So the drive isn't the bottleneck. The Gen 4 drive or the Gen 5 drive. Where are these speeds? I'm not even getting Gen 4 speeds anywhere down the list. I mean, obviously, the GPU isn't the bottleneck here. What's the bottleneck? Is it just the software and just the need for the time to render everything? I mean, something has to work better. I mean, obviously 5090 has more grunt, so it's doing it in 3 minutes and 2 to 5 seconds versus almost 3.5 minutes, right? So that's a nice uplift in performance for rendering, but I don't see the benefit really in having the Gen 5 drive with my reads and write speeds. They're about the same whether you're using a Gen 4 or a Gen 5 drive. Concerning, very concerning. Like, where's my performance here? What if we're rendering in AVI Cineform? Looking at these particular codecs and containers. This is one of those much larger files. Again, I'm not going to go through all the details of the file systems and why I'm testing a certain thing. That's all in previous videos. Please go back and check that out if you have questions. AVI Cineform, small file. Top of the list, 2 minutes, 12 seconds. 9100 Pro with lane split. 5090 obviously at the top of the list, running the chart down, right? Office rig, primary location, the Gen 5 slot was the fastest by a second. With a max read of 146, average 13, max write 2300, average 643, temps are cool as a cucumber. So where's my performance difference between the Gen 5 and the Gen 4 drive? Render time's no difference. And I found the same thing with the 5070 Ti, and I thought, well, maybe that's the problem. Maybe if I had more GPU grunt, that my average reads and writes would go up. But look down the list, that's not it either. So I'm not really getting the benefit of the Gen 4, let alone the Gen 5. Even though the Gen 5, when it can go faster, it does read and write faster than a Gen 4 if given the opportunity, which is, I think, why it's at the top of the list, right? What about the larger 4K file? That 90-minute file? Again, 5090 is at the top of the list over the 5070 Ti, and 990 Pros. primary and secondary in the Gen 4 slot. Faster than the 9100 Pro. So now you're seeing a difference. So when you're having much larger files to render, you do see a slight render difference in speed. But why is it that we're seeing what we're seeing? It's not the Gen 5 that's taking the top slots with your render times. I need to go back and check my numbers there. I think I might have missed some from some numbers right here. So to explain this, the secondary location, the read and the average read is actually coming from the primary drive. That's why it's really 0. And then your write rate would come from whatever drive you're rendering to. That's why you consistently have write rates and average write rates, but not always read rates when you're looking down the list here. So if it's in a secondary drive, it's really not reading from that. It's reading from your primary drive. And one of the things I did look at was, what does it, by offloading that read, does it change the read at all? And really it just shifts it to the other drive. The rates and the demands are the same. It just offloads it, and it doesn't always equate to the secondary drive rendering being faster than if it was the primary location. As you can see, the primary was faster here. If offloading the reading to the other primary drive while you secondarily wrote to the, calling it a scratch drive, and uses a secondary scratch drive and rendered to that drive and only had the write rates and write devices, and that should in theory be faster, but it's not always the case, as that we're seeing here from the data. What about using the larger 4K file with AVI Cineform? I mean, this is like 700 and almost 800 gigabyte file when you render this. 90 minutes, 790 some gig file. So very large files that you're rendering here. And you can see that your write rate does pick up significantly, and your average write rate does significantly, which shows that the codec that you're using really matters in terms of how fast you can write to something, because the hardware has to do a lot more encoding when you're using H.264, H.265, and inter versus interframe, and you're versus AVI Cineform, where you're doing slice, every frame matters, and you're recording every frame, so you just put the foot on the accelerator and just code, right? And so there's much less encoding that needs to happen and much more writing of frames, which is why your write rates and your average write rates are much higher with the AVI Cineform, but also your file sizes are through the roof, right? So as you look down the list, you see 5090s are still at the top of the list, and not always the 9100 Pro. Like you're right there in the ballpark, 1750, 1754. But again, the secondary 990 Pro is probably your best option, but right there, second and third place, is your Gen 5 drive. And there is a faster write rate with the Gen 5 drive. So it's trying. Is that run variance? Is that really Gen 5 performance that we're seeing? It's not the same amount that's listed on the box, right? It's close, I guess. I don't know. Like, but it's not to the level that I thought I was going to get. So what do we do with all this now? Which SSD do you choose now? Like, my previous conclusion was it didn't really matter. Don't waste the money on a Gen 5 drive. And then I didn't want to give up on it. I thought, okay, well, maybe the GPU is the bottleneck. Maybe there's something to be said here if we put better hardware in the system. You know, it's weird to say that 5070 Ti is not enough. Like, that's hard for me to fathom, but maybe. All right, throw a 5090 in, let's check it out. The Gen 5 SSD still had minimal benefit, even with a 5090. There was some benefit in a Gen 4 slot, and there was some benefit to keeping it in the Gen 5 slot, even though you were splitting the lanes. Because I was also shocked that you didn't see the performance hit, even when you've got the grunt of a 5090 trying to overload the bandwidth of the PCI lane and really jam data through there. I thought I was really going to see the drop in performance because we had to share the lane from X16 down to X8. And I really didn't see that. And I can't explain that. I thought this would be the ultimate test to show you that we really shouldn't be splitting the lanes. And I can't make that claim because even when we looked at the Speedway and the Steel Nomad, I was still getting about the same average scores, even if we split the lanes in half. Now, which makes me wonder now, was there something wrong with my setup? Like the only other thing I can come up with is that I was using riser cables, but they were supposedly, and they're written on their Gen 5 riser cables. We did see when we ran the PCI Express test that the lanes were cut in half. So that was a legit test. But if it's not the riser cable, then I don't know how to explain why we didn't see more of a drop in performance. Because obviously I've tested two cards, same system, in different configurations of X16 versus X8 in Gen 5, and I didn't get it really a difference. So if anybody else understands why it was about the same for me, that either there's something wrong with the way I did it, or it's really not that big a deal. I mean, if it's not that big a deal, I should leave the Gen 5 drive right there in the Gen 5 slot, cut my lanes in half, and forget that it's even in there, because it frankly doesn't seem to matter. But I'm not trying to do that if maybe my riser cable was limiting me, even though it's supposed to be a PCI Gen 5 cable, and I should have huge performance differences compared to what I'm getting. I not really think that's the case, but I'm open to discussion. Sound off in the comment section. Help me understand if I went wrong, where did I go wrong? But I don't know how else to explain it. So with that being said, I'm happy that I have a 5090, and there's more testing to come, and there's a water block coming. When I get all of that, I'll keep you guys up to date, and I've got some other cards. They're in the mail. I've got my hands on other cards, and more testing is actually happening. So there's definitely more to come. Let me know what you think of this particular test and these SSDs, because it's not making a lot of sense. Why would you spend the money on a Gen 5 when that's the only performance that you end up seeing? All right. Anyway, thanks for staying tuned. Stay safe. God bless.